If I write down the law, it says that its temperature is body proportional to the difference between the temperature of the body and the temperature in M of the surrounding medium. Okay, this is the idea. Suppose we have an object like this time. If some 30, its temperature is T. Okay, and the temperature of the surrounding is T, right? Then the rate of change of this temperature of this object, that is dT over dt, right? Is proportional to the difference between these two temperatures. Okay. Is M minus T. Okay. That is the rate of change of temperature of the object is proportional to the difference between the temperature of the object and the temperature in the environment. Okay. So the definition makes sense because suddenly temperature of this object would raise the environmental temperature. Then what would happen to the rate of change of the temperature? It would become zero. Right? That should happen, right? Because if they are the same temperature, they cannot interchange heat. Right? So again, for this proposal, we can add the proportional constant and then this is how the equation would look like. The rate of change of temperature is equal to negative K times T minus Tm. Yes, sir. Send this. Constant is possible. This is also very easy separable equation to solve. Right? Can you give a try? Solve this. You consider your initial condition as zero. Temperature at time zero is going to be T naught. Can you give a try to solve this equation? First try to separate variables and then integrate, right? You had to use this problem. Integral of x minus a is going to be equal to natural logarithm of x minus a. Right? This is how to use that. Did anyone get the answer? Solution to differential equation.
T minus TM equals C. And then
Yeah, it's some exponent. Yeah.
minus KT.
Yeah, let's see. Let's see. I think we might get exponent. Yeah. Let's see. So first I would separate. So I would get 1 divided by t minus tf dt with minus k dt. Okay. Then I would integrate t minus tm dt is equal to minus k integral of dt. Okay. Then integral of this kind of right. Instead of x, I have capital T, and instead of a, I have tm. So this is going to be natural logarithm of capital T minus tm is equal to minus k t plus the constant. Call the constant as c, right? So then I can write t minus tm as e to the negative kt plus this constant. Okay, equal to e to the negative kt times e to the c. Again, e to the c is a constant, so this is equal to e to the negative kt times c naught. Okay. So I have tm is equal to e to the negative k t times c naught. Now I'm going to use the initial condition to find the value of c naught. Okay. I know that initial temperature of my object is going to be k naught. So I would plug 0, simple T equals 0, then I would get T0 minus Tm equal to e to the 0 times C naught. So C naught is going to be equal to T0 is T naught minus Tm. Okay. Right. Now I know C naught, that means I know the solution. So T minus Tm is going to be equal to e to the negative kT times T naught. T naught is T naught minus Tm. So the temperature at time T is going to be equal to Tm plus e to the negative kT T naught minus Tm. It is the solution for the Newton's law of cooling. Any questions about this example? Question? Okay, so I would go into the next one. Next application, that is the mixing problem. The way that I am continuing it is different from the things that is appearing in the left node, right? In the left nodes, these have not been solved. These ODs have not been solved, but I would like to solve it. Then you can have some idea about how solve ODs using separable methods. Right? Then this is what it says. You have tank. You have tank. You can input fluid from this side and you can output fluid from this side. Right? You have inlet and outlet. Initially this tank is filled to volume of V naught. So the initial volume is V naught, right? V naught, and there's a salt concentration in this tank. Right? So this time equals 0. There's a salt in the tank. So initial salt concentration. Concentration is C naught. So you have volume V naught. So initial salt concentration is C naught kilogram cubic meter. So what is the total mass of salt inside this volume? Concentration is C naught. Now, initial volume is V naught. So what can you say about initial mass of salt? What is initial? V naught times C naught. Because If you take 1 cubic meter, you have C naught kilograms. Right? Now we have P naught. So is C naught times. Okay. This is the initial state, right? Then we are going to do something like this, right? Then we are inputting for this point the source solution with concentration CIK to right? So in I kg cubic meter. So another salt solution would come to this tank through this pipe, right? And its concentration is CI kilogram per cubic meter. Okay? And meanwhile, we are using this outlet to take the solution in this tank. Output from it is flowing out at Q naught. Q naught. And this input rate is QI. Okay. That means QI cubic feet of this solution would enter to this tank within a second. Right? This is the input rate and this is the output rate. And this is the output rate. Output rate. And this is the input rate. And this is the concentration of the inserting liquid. Okay. Okay. Right. And the problem is now this is the initial condition, right? Initially you have V naught and the liquid is flowing through this pipe and the liquid that is in the tank is flowing out through this pipe. Right? So yeah, I know the input rate and output rate. Now the problem is suppose after time t, what would happen? This is at time t. The liquid is flowing at a rate of Qi. And the liquid that is flowing into this tank has a concentration of Ci. But now we do not have any idea about initial. Well, initial value is we know, but now we don't know. Okay. But it would remain same. If one condition is going to be hard, then the volume is going to remain same. What is that condition? If input rate is same as the output rate. Now we are inputting some liquid from here. The rate is Qi. Now the liquid is flowing out through this pipe. That rate is Q naught. Okay. What would happen if Qi is equal to Q naught? Then the V naught would remain same. Right. But in this case, we do not have any idea about Qi and Q naught. Right? They might be different. So that's why I mark this as VT. Okay. Right. If it is not cubic meters per second. Okay. The problem is to construct some differential equations to model this. Right? So let's try to have some model. So first try to are there any questions about this idea? We have an initial value and initial concentration. Right? So what would happen to this initial concentration? Now, initial value means we not and initial concentration is say on. So now a liquid which has different concentration would enter into this tank. So the concentration, the salt concentration inside this tank is going to change. Right? Let's try to obtain some differential equations. Right. So first equation is what is the rate of change of the volume of this tank? What is the rate of change of the volume? What can I say about rate of change of the volume? It's going to be Qi minus Q naught, right? Input flow rate minus output flow rate, right? Because if these two are equal, volume is not going to change. Okay. I have this equation. This is one differential equation. Right. Let's try to obtain another differential equation that would connect the mass salt mass of this tank. Let's try to okay. Suppose empty mass of salt inside the tank at time t. Okay. Right. We know that M0 is initially the mass of salt is C0 times V. Okay. The initial mass is salt. Okay. Right. How do you find the rate of change of salt? Is given by input salt mass, the rate of change of input salt mass minus rate of change of output. What is the rate that salt that suppose this rate is Qi, right? At 1 second, how much mass of salt would enter into this tank? Concentration is here and Qi cubic meters per second would enter. That means within 1 second, Qi cubic meters would enter into this tank. Right? So what is the mass of the salt that would enter to this tank within 1 second? Its concentration is this. Its rate is Q1. What is the mass of the salt that enters into this tank within 1 second?
QICI.
Yeah, QIC. Right? I minus. Now we have time t, right? This case is Same for any time, right? But I need to find the rate of change of the salt mass inside the tank. Now this is I know that this is the mass of salt that would enter the tank within 1 second. Now, can you tell me what is the mass of the salt that would go out of the tank within 1 second? Now we have to go to this diagram, right? Because we had time t. So what can I say about that? What is the mass of the salt that should go out of the tank within 1 second? We know the rate, right? But we do not know the concentration, right?
Yeah.
Now, what is the salt concentration of the tank? Now, what is the salt concentration in this tank at time t? What is the salt mass of the salt at time? It's empty, right? So, what is the salt concentration of this tank at time t? Salt concentration. We know the mass of the salt, so I would call it salt concentration at time t. Salt concentration time t. I would call that as CT. CT is MT divided by PT, right? Because I know that mass of the salt at time t, that's empty, and volume of the tank at time t is PT. So then I can find the concentration. Right. So what is the now? Can you tell me what is the mass of the salt that would go out of the tank within 1 second? Rate of yeah. At what rate salt would go out of this tank?
Q naught times T.
Q naught times CT. Concentration. I would say the mass of salt goes out to the tank within 1 second. That is CT times Q naught, right? So this is the input rate and this is the output rate. CT times Q naught. So have this equation. dMT over dt is equal to QIC by minus CT is MT divided by dt. Okay. These are the two differential equations that governs this system. Okay. So in this case, I found the rate of change of salt mass is given by. For that, I need to consider the input rate of the salt mass and output rate of the salt mass. Right? Because that difference would cause to increase the salt mass inside the tank. Okay. The rate of input salt mass and the rate of output salt mass. The difference between them would increase to change in the salt mass inside the tank. Okay. Any questions about that? This might be difficult example, but in tomorrow's class I would do more examples. This is the construction, but we don't know more examples. This idea. Any questions about this? And I would go into final example, that is RC circuits. That I try to recall some basics of physics, right? So have you done any course related to electric circuits, capacitors, inductors? I would recall basics. So if you have an AC circuit, suppose you have a capacitor. This is the notation for capacitor. So what does capacitor do? It stores charges. Right? It stores charges and we can generate a current. So use right? The capacitor, suppose current flow to the capacitor like this, then voltage would build up in this direction. That is, this is positive and this is negative. Okay. And this voltage is, I would call that voltage as VC. Okay. Then this current is given by IC. C is given by the capacitance times the rate of change of voltage. Capacitance would depend on the capacity, right? It depends on the material. That you made this capacity, right? The equation that is related to capacitance, and if you have an inductor, in this case, C is the capacitance. Suppose you have an inductor. When we have an inductor is kind of a point. Right? So, if you consider transform, it's also kind of inductor. Right? If we have inductor, then we are considering about inductors. It is also materialistic. Inductance would depend on the coil. Right? It does not depend on current or voltage. Right? Suppose current would flow, then voltage would build up. Bigger. VL is going to be equal to IL n times rate of change of current. The resistor is easiest, right? Suppose we have a resistor. Then we have a resistor. voltage. VR is given by R times pi r. Have you seen these things before? Have you heard about Kirchhoff's voltage law and Kirchhoff's current law? We are going to consider RC circuits because we can consider RCL circuits because if we have all those straight, then we get a second order differential. But if you have RNC or RNL, then we get a first order differential equation. Right? Then I would draw a small circuit diagram. Suppose here's a voltage source. So this is the voltage source E. Right? Resistance is R. And you have a capacitor. Capacitance is C. Is positive, right? And this is the positive direction of this voltage source. So I would mark the current in this. Actually, you can mark the current in any way there. So this is the voltage build up through this. Times the voltage build up through this capacitor. Right? The voltage build up through this voltage source. Right? Voltage source would supply the power. Right? So how do we apply Kirchhoff's voltage for this circuit? What is Kirchhoff's voltage source? It says that if you consider any closed path, the total voltage drop would be equal to zero. Right? If you consider any closed path, the total voltage drop is going to be equal to zero. Right? So I'm going to take the closed path. Right? So then, Kirchhoff's voltage says that Hence law says that the total voltage drop along closed path is equal to zero. Okay, so let's apply Kirchhoff's voltage. Right? Let's go along this direction, right? Clockwise direction. Right? I have E. Wait. Direction. So I have E is in the direction that I'm moving. Right? But what can you say about VR? It is in the opposite direction that I'm moving. So E minus here. Okay, what can you say about VC? It is also in the opposite direction that I'm moving. Right? It will be equal to 0. Okay. Right. It would depend on time, right? So Any questions about Kirchhoff's voltage? What is Kirchhoff's current levels? It would say that if you take any node, the total current, the current in that node is equal to, suppose here a node, and you have some current, I1, I2, I3, and then I1 plus, I2 plus, I3 equals 0. Okay. And if I mark the current in the reverse direction, suppose I will mark this current in the other direction, then I will get negative. Okay. Total current. Come to a node is equal to 0. Okay. I1 would come to this node, I2 would come to this node, I3 would come to this node, I4 would go away, but negative I4 would come to this node. Right? So this is the equation. This is Kirchhoff's current law. Now I would continue this idea in the next class. Right? I would construct the differential equation in the next class.